Welcome back. Now we're ready to continue. We have our projectiles. We're spawning a pair of them, and that's about all we're doing. And we'd like a lot more features, but before we continue, in this video, we're going to learn about blueprint functions. Now we know about them a little bit. We've been calling them. They're these blue nodes here in our event graph that have input and output execution pins, and some of them have input pins for data and output pins or return pins for data. Now, there are a large number of functions that exist already, but we can create our own functions. We can create functions from within an actor, and those functions are going to belong to that actor class, just like our variables do. When we create a function from within an actor class, we often call that a member function. So we can create our own functions. And this can greatly reduce the complexity of our blueprint nodes, as they can get out of hand quite quickly. Sometimes an event graph that's gotten out of hand is called spaghetti code, often because the number of crisscrossing wires resembles spaghetti. So we can make our own functions. And functions should be restricted to a specific task, like our getAllActorsOfClass node. This function does one thing. It gets all actors in the level that are of a specified class. We could make a function for retrieving and storing our target pawn, and it can do these actions here. So let's make our own custom function that belongs to the BPBot class. We do that by going to the My Blueprint panel and clicking +add, and instead of variable, this time we're going to choose function. And we have to give it a new name. We're going to call this store target pawn. And in this function, we're going to get the one and only pawn in the level and store it in our target pawn variable. So we could go back to the event graph and get the nodes that do this, highlight them, Control-C to copy them, and come back to store target pawn, Control-V to paste them, and hook them up to the purple node. The purple node can be selected. It has its own details panel. We can even add inputs for data here so that our function can have its own input pins, and we'll be doing that later. For now, this is all our function needs to do. And when we call this function, we're going to get these nodes executed. Notice I've been saying words like call. Using a function is also referred to as calling the function. This is terminology from programming. So back in our event graph where we're using these nodes, it's said that we're calling this function. And sometimes you'll hear me say that we're passing data into functions. That's also a programmer term. Passing data into functions is just providing data for that function as an input. So now that we have a function called storeTargetPawn, it has its own tab next to the event graph. We can close that tab, and we can also open it back up by double-clicking it under the Functions section in the My Blueprint panel. And that opens it back up, and we can make changes if we want to. So when this function is called, it's going to call getAllActorsOfClass, make sure that its first element with an index of 0 is valid, and then store that value in target pawn. So in event graph, we're going to remove the nodes that are doing that. I'm going to highlight and delete them. I'm also going to delete event actor begin overlap because it's in the way. And we're going to call store target pawn. We can do that either by right clicking and searching for store target pawn. Notice that it's here. It's one of the options now. We can get the node and notice, look, it's a blue function node, but this is our custom function node. Pretty cool, right? Another way to get this node is to simply come over to our functions section and drag store target pawn onto the event graph, and we'll get the node that way. I'm going to delete that one, and we're going to call store target pawn straight off of begin play, and then we can hook the output execution pin to our nodes that follow. So we've just taken a handful of nodes and condensed them down into one handy function that stores our target pawn. Pretty nice. Now, you may have noticed that some of our nodes have input and output execution pins, and some do not, like getSocketTransform. This is a function too, but it doesn't have input and output execution pins. This is called a pure function. Pure functions don't have input and output execution pins, but they do perform some kind of task and return some kind of value, and these nodes are executed every time their value is used somewhere. Here it's used in spawn actor BP, blaster beam. As soon as this spawn actor node needs this value, this pure function will be executed and will return that value. Well, we can make pure nodes as well, but these are typically for performing a quick calculation and returning a value, and that's it. Let's make our own pure function. I'd like to make one for simply finding the correct rotation, the target rotation for our R-interp2 node. We can make a pure function for getting the actor location using find lookat rotation and finding the rotation to look from our actor location to the target pawn location. That's what I would like our pure function to do. So I'm going to add a new function in my blueprint. New function. I'm going to call this find target rotation. And we're going to do what we did here in the event graph. We're going to get our rotation using find lookat rotation. Let's copy those nodes and come back into find target rotation and paste them in. But we need to return a value. So to specify a return value, we can click on find target rotation, and in the details panel, we can add an output with the plus icon here, and we can choose its data type. We're going to choose rotator, and we're going to call this target rotation. And now our function has a return node, and we're going to return the value calculated here. So we're going to hook that in right there. And if we go back to our event graph and right click and search for our new function, find target rotation, we can get it. Here it is. Now it's not a pure function, is it? It has an input and output execution pin. We want this to be pure, much like these nodes here. So we can simply select find target rotation. And in the details panel, we can check the checkbox for pure. It says, force this to be a pure function. Well, yes, please. If we check that, now look at our node. It's nice and compact. It doesn't have execution pins. It only has a return value called target rotation. We're going to hook that in to target and get rid of these nodes as we don't need them anymore because we now perform that calculation with our new pure function, find target rotation. Excellent. Now, the way we've created these functions is actually the hard way. By going and clicking add, creating a function, giving it a name, pasting in nodes, that's the hard way. The easy way is as follows. I'm going to drag my event tick back, and I'd like to make a function that does all this stuff here. So instead of making a new function and pasting these nodes into it, I'm just going to highlight all of these nodes, right-click on one of them, and select collapse to function. As soon as I do that, they're all collapsed into one handy function, and this function is going to interpolate our robot's location. So I'm going to call this interp rotation. Notice that it automatically has an input of float type called delta time. So highlighting and collapsing to a function is the easy way to make a function. And if we double click on interp rotation, our nodes are here. Our function calls our new blueprint pure function, find target rotation. It's using R-interp2. It's doing exactly what we were doing before, but it's compact into our nice new function. And notice that R-interp2 is hard coding 8 for the interp speed. So why don't we make that an input to our function? We can click on interp rotation and go over to inputs, click on plus, and add an input parameter to our function. That's what these are called, input parameters. I'm going to call this interp speed and change its type to a float. And we're going to take interp speed from our interp rotation input pin and hook it straight into interp speed here, compile that. And now if I go back to event graph, we have an input here, interp speed. And we can pass in a value such as 8, Or we can make this class even more versatile and have a member variable. I can right click on this and promote to a variable and call this rotation interp speed. I'm going to compile and just make sure that it still has its value 8 as the default value. So now we don't have to go in and find where it's being used in our event graph. All we need to do is select rotation interp speed on the actor itself and change it here. And remember, we could even make it instance editable if we want to change this per instance in the world. So now we know how to make functions, and we can make our blueprint graphs a lot neater. Event tick already looks a lot better. And another organization method that we can use is comments. I'm going to highlight this interp rotation call along with that interp speed variable and simply press C on the keyboard to create a comment. And we can describe what's happening here. Interpolate rotation to target pawn. So commenting sections of blueprint logic is a good way to organize the blueprint graph. We can even color code these comments. Notice that if we select the comment, we have a comment color, and we can change it if we like. We can make it blue. We could change its font size. If I zoom out, changing the font size makes it bigger, but I'm going to leave it at 18. And an option that I like is show bubble when zoomed. If I check that, we have the bubble here, and if I zoom in, it goes away, but if I zoom out, I can see it, and that makes it really easy for me to navigate throughout all my blueprints. So comments are a great way to organize our code. Okay, so that's all the functions I'm going to create. As the rest of these nodes, they're going to be changed somewhat. But for now, we've just gained a lot of new skills. We know how to make functions, we know how to collapse nodes into functions, and we know how to make a pure function which doesn't have an input or output execution pin. And we know that this function is executed every time its values are used anywhere in the event graph. And finally, we've learned about comments and how we can customize those, so our blueprint is looking a lot better. Excellent job, and I'll see you soon.